In this video, we are going to learn um, some of the physiological basis of fluid distribution, and we're going to compare 5% dextrose and normal saline. So what we're going to start off with is to calculate or estimate the total body volume of a average man. So if we take an average man as 70 kilograms, and we know roughly about 60% of the body is fluid. That gives us a total of 42 liters of fluid. So now what we're going to do, I'm going to represent the total body fluid as a rectangle. So that's your 42 liters of fluid. About a 2/3 of this fluid, so that's 2/3 of this fluid is intracellular. So we're going to put down intracellular fluid, and the rest, a third of it, that's a third, is extracellular fluid. So 2/3 of 42 liters is 28 liters, and a third of 42 is 14 liters. So of the extracellular fluid, about a quarter of it, so that's a quarter, is plasma, which I'm going to represent as P, and the rest of the extracellular fluid, which is 3/4, is interstitial fluid. So 3/4 of 14 liters is about 10.5 liters, and a quarter of 14 liters is 3.5 liters. So you can see that plasma is a relatively small proportion of your total body weight, body fluid. So there are a couple of other things we need to know. One is that if you look at what is separating the intracellular fluid and extracellular fluid is the cell membrane. Now, cell membrane is a semi-permeable membrane, which means that water freely moves along the membrane, but sodium has to move with the aid of a pump, and sodium moves out and potassium moves in. Now let's have a look at what separates the interstitial fluid and plasma. Well, that's the vessel wall, essentially, at the capillary levels. And this wall is permeable to both water as well as sodium freely. Now, let's now assume that we're going to infuse a liter or 1,000 mils of 5% dextrose intravenously or into the plasma. And essentially that's this compartment that you're going to infuse it into through a Venflon. Well, let's just calculate how this liter of 5% dextrose is going to get distributed throughout the body. Well, we already know that 5% dextrose is the same as water, and we know that the water infuses through the capillary wall into the interstitial fluid and into the intracellular fluid, and essentially this liter of dextrose spreads equally throughout the body compartments. So which means that 2/3 of it, it's going to be intracellular. So 2/3 of a liter is around 666 mils, and a third of it will be extracellular fluid, and that's around 334 mils. These are just estimates. Furthermore, we know that of the extracellular fluid, 3/4 of it is interstitial fluid. That's fluid outside the plasma, but also outside the cell. And that is around 250 mils or thereabouts. And this is interstitial fluid. And that leaves around 80 mils in the plasma. So you can immediately appreciate that when you infuse a liter of 5% dextrose, only 80 mils of this fluid remains in the plasma. So if you want to bring the blood pressure up in resuscitation in a hypovolemic patient, 5% dextrose is not a great choice. Now let's just take another example. And let's take the example of 1,000 mils of normal saline, which is 0.9% normal saline. That's essentially 9 grams of salt dissolved in a liter of water. Well, this is going to be infused into the plasma, which the water and the sodium then infuses freely into the interstitial fluid. So the water and the sodium get distributed into the extracellular fluid throughout. However, there will be no movement of sodium, or for that matter water, into or out of the intracellular fluid, because the infused saline or the salty water is normalized, which is essentially the same concentration of sodium throughout the body. So there is no change in the osmolality of the extracellular fluid. So essentially all that fluid that is infused remains in the extracellular fluid, which then means that essentially 3/4 of it is into the interstitial fluid. In the interstitial fluid, which is 750 mils, and 1/4 of that remains in the plasma, which is 250 mils. Just for comparison, if you were to give alba or albumin, nearly all of that remains in the plasma, and that's because the molecules are too large to leave the vessel wall, and almost all of it remains in the plasma. So alba or the gellifusin all remains in plasma. That's just a summary of the differences of the distribution of 5% dextrose, normal saline, and alba or gellifusin. Thank you.